Good morning, friends. Here we are going to learn about pile load test today. So, before we go on to the pile load test, let us know the basics about a pile. So, what do you mean by a pile? In places where you don't have any hard stratum or a hard layer of rock in the top surface, you have to go for deep foundations. Why is it so? So, if you see in many places, a hard rock or a hard layer of sand or a soil is seen only after a depth of 30 meter, 40 meter, 50 meter, etc. So, it's impossible to make an excavation up to that depth. Okay, it's not economically feasible, and otherwise also it's very difficult to keep on excavating even if it's with the help of an equipment. So what are we going to do? In those cases we provide deep foundation. So what do you mean by a deep foundation? Deep foundation means it's a foundation which starts from the building and it will end at the stratum where the hard foundation is formed. In short, it's a sort of a pipe or a rod which will connect the lower part of the building to the hard stratum. Okay, so this pipe or this tube helps in the transfer of the load from the base of the building to the depth of foundation, depth of the hard foundation. Now, this pile load or a pile is seen under the ground. We cannot go and do the test in each layer. Even while we are constructing a pile, it's a bit difficult to see how properly it has been constructed. We cannot excavate the entire depth and see whether it was properly excavated or properly compacted, etc. So what we do is, after constructing a pile, we'll do the pile load test. Okay, the pile load test is done on the field and hence it is one of the most reliable tests that has been done. Now we learn about pile load test. It is written or mentioned in IS 2911 and it is used for the determination of allowable loads on pile. Okay, as I told you before, it's the most reliable test because it is being done on field and it is most suitable for cautionless soil, that is a soil without any caution. Okay, this work is done on a working pile or a test pile. Working pile is the pile which has been cast for the purpose of being under the building itself. While a test pile means a pile which has been casted at a different location in the same site, okay, a bit away from the structure, and it is used only for the test purpose. Okay, the pile load test can be done on a single pile or a group of piles. Okay, and it's used for the determination of vertical load bearing capacity, uplift load capacity, and lateral load capacity, which is the ratio of the vertical load bearing capacity. The load is done of two types: maintained load test and cyclic load test. Now we will learn about the maintained load test. So before we go start the test, why do we have to do the pile load test? Pile load test is used to find out the settlement under working load. That is, once the building has been completely constructed, we have to find out whether it will settle and how much it will settle if the building comes up. Another thing is to find out the maximum multiple bearing capacity of the pile, that is, the maximum load it can carry even in the extreme cases, and to establish as a proof of acceptability. Whatever numerical analysis or whatever calculation we do, it cannot be shown to the public and say, see, we have done so much of work, this will of course withstand the strength of time. But while we are doing pile load test, we are doing the test on a pile which is already constructed. After the construction of pile, before we start the building, we are doing it. So the people will have more trust on it rather than on the numeric analysis or the static analysis or any other test that we are doing. Okay, so now you can see here, this is the pile load test diagram. Okay, you can see a main bar here, a reaction beam here, and there are two dial gauges which are placed to measure the settlement. You can see a hydraulic jack here. This hydraulic jack will transfer the load to the test pile from this main beam. The main beam is equivalent to the structure, and this main beam will be loaded with the help of soil or gunny bags or ACC bricks, AAC bricks. bricks or any material of heavy load. Okay, it will be loaded and that load will be transferred from the main beam through the jack to the test pile. Two dial gauges are placed to measure the settlement, and now you have seen the diagram. Okay, this is a schematic diagram. Now this is the actual picture of a pile load setup on the field. So you can see the uh, settlement dial gauges that has been placed here. Transducers are also placed here to measure the force. Okay, so now we'll move on to the procedure. The procedure means what you're going to do is the loading post or H beam and hydraulic jack is provided above the test pile as you have seen from the figure. The hydraulic jack supports the gravity loading frame. The loading is done with the help of sandbags or concrete blocks as I have already mentioned. Okay, excuse me. Tool dial gauges are used for the measurement of settlement that also I have shown you, and the pressure gauge is placed near the hydraulic jack to measure the loads. Okay, first what we are going to do is a minimum seating load is applied onto the pile, onto the beam before the test is started, so that every instrument that is placed there will be stable during the entire course of the experiment. We are providing a little force so as to make everything stable, and then the, during the entire course of the experiment this equipment will remain stable. After keeping it so, we will remove the load and we'll start the test. So here are the few site pictures. Here we have used sandbags. Here concrete blocks are being used. This is a setup in the field. You can see the transducers that are connected to find the pressures, and these are the hydraulic jacks. This is a close-up, and this is a transducer which is used to find the pressure, and these two are the dial gauges. Okay. Now we'll go to the procedure. So as I told you, after the initial seating load, the load is being reverted back to zero. After that, the load is again increased in regular increments of 20% of the design load. So 20% of design load is done. 20% of the entire load is given at regular increments. So and each increment is sustained or kept the same till the settlement is not more than 0.1 mm per hour if you are using a sandy soil, and in case we are forced to use it in a clayey soil, the settlement should be 0.02 mm per hour. Okay, otherwise after the settlement becomes stable for 2 hours also we can change the load. Okay, so if you are giving one particular load, we have to keep it steady till the settlement is not more than 0.1 mm per hour in a sandy soil and not more than 0.2 mm per hour in a clayey soil, or till the settlement remains constant for 2 hours. Under each load, after this procedure, we can increase the design load. Increase the load. You keep on increasing till it reaches the design load, and under each load, the settlement is continuously being observed. The loading is kept on continuing till twice the safe load that we have calculated from the static analysis, or till the settlement reaches the specified or the permissible settlement that is obtained from the code for any particular building. Then the load is unloaded at the same decrements and settlement is measured after each 24 hours. Okay, so we have increased by 20%. Same amount of load is removed every 24 hours and the settlement is noted after 24 hours of decreasing the load. Then the load settlement graph is plotted. From the load settlement graph, the ultimate load is measured and as shown below. Okay, this straight line that you can see here is the loading curve, and this is the unloading curve, and this one is your net settlement. This is how you will be measuring the diagram. Now, after you have got a normal load settlement curve, this is a normal load settlement curve. Here I have taken only the loading part. How you can find the ultimate loading capacity? So if it's a sharp curve, that is here there's a sudden change in the slope. If there's a sudden change, you can take that to be the ultimate bearing capacity. In this case, you can see a linear portion is there. The starting point of the linear portion is taken as the ultimate bearing capacity. In this case, you can see there are two general slopes. So what you will be doing is you will be taking the initial tangent, final tangent, and the meeting point of those tangents will give you the ultimate bearing capacity of the pile. Okay. Now you have obtained what is the ultimate loading bearing capacity. Okay, now you have to find the allowable load. How we will find the allowable load? So there are three conditions according to IS code. The first one is it is 50% of the load at which the total settlement will be equal to 1/10 of the diameter of the pile. Okay, or it will be 2/3 of the final load which causes the settlement of 12 mm. That is, you have to determine the load at which settlement is 12 mm, and 2/3 of that will be the allowable load. Or if you allow net settlement of 6 mm, you have to find that load, and it will be 2/3 of the final load. Or as I told you, this is the 50% of the ultimate load at which total settlement amounts to 1/3 of the pile diameter. Okay, now the safe bearing capacity will be equal to ultimate bearing capacity divided by factor of safety. Okay, this safe bearing capacity is what you have to check with the already determined capacity from the static analysis. If these both are matching, you can know that the pile is successful. If at all the safe bearing capacity we obtain from the field is lesser, we have to leave this pile and add another pile, or you have to remove the pile and insert another and construct another pile. I hope this portion is clear. Thank you.